Okay, practice example 15.5b gives us the equation of PCl5, gas in equilibrium with PCl3, gas, and chlorine gas, Cl2. You tell us that Kc for this reaction is equal to 0.0454 at a temperature of 261 degrees Celsius, and if I add 273 to that, that is 534 Kelvin. Okay, they tell us initial pressures, and the initial pressure, I'll just write it underneath, for PCl5 is 19.7 atm. For the phosphorus trichloride, the initial pressure is 2.19. These are partial pressures. And chlorine's partial pressure to begin with is 0.88 atm. They want us to find out in which direction the reaction will proceed, to the left or to the right, in order to reach equilibrium. And so to answer this, we have to calculate a reaction quotient, Kc, to compare with, or Qc, pardon me, to compare with this Kc. Alternatively, I could compute a Qp and compare it with a Kp, so I would have to convert this Kc to a Kp. And I think I'll go that route. And so first of all, let's compute a reaction quotient in terms of pressure, Q sub P. Now these are atmosphere units, and they really should be units of bar for KPs or QPs. And the way that we convert atmospheres to bars, units, and that is a conversion factor given on a data sheet on an exam, is to multiply everything by a factor, conversion factor, and let me just slide this over to show you, and then I'll slide it back. So we would multiply each of these by the number 1.01325 bar. There are this many bar per atmosphere. So it's pretty darn close, and you'll see in the book in examples like this where precision is not that important, but we're just getting an idea of to compare K's and Q's. Then we just leave computed in atmosphere and go ahead. But I'm going to convert it to the proper units so that I get a QP in the proper units. So when I multiply each of those by 1.01325, let's slide it back over, and I'll write the corresponding units, bar units, for these initial partial pressures underneath. So 19.7 becomes 19.96 bar, and the 2.19 becomes 2.22 bar, and the 0.88 atmosphere becomes 0.89 bar. And so I can compute my Q sub P, and I look at the balanced reaction. It is balanced, and it's 1 to 1 to 1. So my QP is equal to 0.89 times 2.22, all divided by 19.96, and that comes out to be 0.0989. Now I need to compare QP with KP, but I've been given a KC. This KC can convert to a KP value by putting it into the equation 0.0454 times RT. Remember the value that we used for R was the 0.08314 liter bar per mole Kelvin. And I'm multiplying that by my temperature in Kelvin, which I've already converted to 534. And then the delta N value is 1 plus 1 minus 1, which is just 1. And this comes out to be 2.015. And so I'm comparing my QP with the KP value. And because the reaction quotient is less than the corresponding equilibrium constant, the reaction will spontaneously proceed towards the right, the product side, in order to reach equilibrium. And so it'll go right in order to reach equilibrium, or towards the products. Very good.